Hi, this is Victor Morganti here from FactEngine. Today we'll be looking at the FactEngine architecture. And before we dive into that, let's have a look at what FactEngine is. So FactEngine is a way to query databases in either natural language or controlled natural language. And we've got FactEngine open in front of us here inside the Boston conceptual modeling software. So FactEngine is available as a web API or as a set of DLLs, direct link libraries, that you can use to return queries for you in your native database language, SQL, Cypher or TypeQL. And we're showing it inside the Boston conceptual modeling software here. So we've got a database schema open in the left hand side. It's in the Model Explorer in Boston, and that's for the Northwind database as provided by Microsoft. Now, those familiar with the Northwind database, it's a database for capturing information about orders placed by customers for products, placed by customers for products, and where a product has a supplier, and where an employee took that order, and orders were shipped by a shipper. Customers have customer demographic, and employees service territories that are in regions. Now, with FactEngine, you can say something like, which customer bought a product that is supplied by, and we've got a shortcut there, and let's pick a supplier straight from the database, Escargot Nouveau, and there's a controlled natural language query that we can run against the database. So let's execute that, and we've got our results come back. Now, FactEngine also allows you to write natural language queries, and if we get rid of that controlled natural language query, and we can ask the same question just in straight natural language without having to use the controlled natural language. So we can say, show me the customers that bought products supplied by, and here's the name of our supplier. So that's going to go away and convert to controlled natural language and then execute. So there's the name of the customers and the products that they bought, and they were supplied by Escargot Nouveau. So there's the controlled natural language query. Here's the database query in SQL. That could be Cypher for Neo4j, or SQL or TypeQL for TypeDB. So, and there's our results. So we went from natural language to controlled natural language to get our results. Now, that operates over our schema, which we can view as either a property graph schema, and if we control click on, say, employee, we can see the properties for the employee node type in this property graph schema, or we can view that as a entity relationship diagram, or a object role model, or a whole suite of object role models which define our overall schema, which can be presented on one or more pages as a entity relationship diagram or a property graph schema. So the architecture behind FactEngine works this way. So we've got your data sources here. So depending on your architecture, you could have one or more databases linked up to FactEngine. But say typically you might have one database, which may be with the database you've got a structured schema. You could also have structured, unstructured data in your data source. On top of that, we've got FactEngine and a ontology or model as a semantic layer that sits over the top of your database. And it's this semantic layer that allows us to do controlled natural language queries very easily against our schema. And on top of that again, we're using a trained large language model to effect what's known as a semantically enabled database to let us to do schema-aware semantic queries or semantic search. Now, in this diagram here, I'm differentiating FactEngine from neural databases which don't really exist yet in 2023 at the opposite end of the scale, where you might have every single bit of your data in some sort of neural network, neural database. You might picture, say, Google's architecture as some sort of neural database that you can ask semantic queries or semantic search against. But would you use, say, Google to store every single product in your product catalog or all your account details for your customers, etc.? Possibly not. Somewhere in the middle here we've got vector databases, and that use vector embeddings of the meaning of various sentences and things like that, typically used for unstructured data. And what we're finding is that FactEngine is much better suited for structured data or unstructured data, so where you take unstructured data and put it into some sort of structure to query it. And having a trained large language model that is schema aware over the top. So if I go to the next slide, what we end up with is a schema aware large language model which interprets our natural language queries, converts them to a FactEngine controlled natural language query, and which is executed against our data sources. So we can watch that in action again. So if I go back to FactEngine and get rid of that controlled natural language query, and I'll ask a query, so show me the employees that took orders for products on or say in December 2017. So that's a semantic search, and we need to be able to resolve that into a schema aware controlled natural language query to be able to get our database query in, say, SQL or Cypher or TypeQL, and we farm that out to the large language model that's been trained to understand the schema of our database. We're going to convert that to controlled natural language, and we've converted that to which employee took an order, that is for a product that was placed on the order date and the month, the 12th for December, and was placed in the order date year 2017. So we're looking at in the results the first name, last name, order, the product name and the order date for orders taken by employees in December 2017. This video has been made in 2023, so it's old data in the Northwind database. Here's the query behind that. So we've converted our natural language query to controlled natural language to a database query, in this case SQL, and we execute that to get our results. Now this is all made possible because the FactEngine architecture sits over what I call the Richmond architecture. And the Richmond architecture, this is a busy diagram, but it basically is an affected 4-layer architecture, where at the top we have a ORM meta model acting as a meta model. We have conceptual modeling language meta models inside our object role modeling meta model, and we can have various languages, so object role modeling, entity relationship diagrams, property graph schemas, even use case diagrams, data flow diagrams, etc. could be put into the same architecture, and the user works with the language of their choice, and that's all tied together under the Richmond architecture so that the diagrams are interlinked. So we can have a look at that just briefly. if I go to, say, supplier here and change its name to suppliers, now that change should be affected automatically. We'll just give that time to finish. In our property graph schema, so that's been changed to suppliers in our property graph schema as well. So it's the same with properties. If we change any of the properties, they're affected directly from one modelling language to the other modelling language, and in Boston to another modelling language again, so object role modelling. So this object role model is linked to this property graph schema, which is linked to this entity relationship diagram, where the entire Northwind database is viewed as a multi-model database. So Boston, the conceptual modelling language, software, treats every database as if it were a multi-model database. So we're looking at the entity relationship diagram, which has a corresponding property graph schema and object role model, and Fact Engine sits over the top of the four-layer architecture that defines our schema, so that we have a schema-aware semantic search architecture, so that we can ask questions in natural language and have those converted to controlled natural language to execute over our database. So I'll give you one more example of that. So let's say show me the customers that placed an order for products that have a supplier that is based in let's say the UK. So this query should work. So let's convert that to controlled natural language. And the model does not contain supplier. Okay, we've changed supplier to suppliers. Let's fix that and change that back again. And go back to our query, execute that. And there's our results. So show me the customers that placed an order for products that have a supplier that is based in the UK has been converted to which customer made an order that is for a product that is sold by a supplier that is based in the country UK. That's been converted to SQL, and there's our results there. So that was a very good example, really, because we showed that the query is schema aware. So we had previously changed supplier to suppliers, didn't recognize that, we changed it back to supplier, and now our query effects on that successfully. So thank you very much. That's the Fact Engine architecture. So to recap on that, Fact Engine sits over the top of the Richmond architecture, which treats every database as if it were a multi-model database. We have a ontology or a model as a semantic layer that sits over your data sources. The natural language queries are affected by a schema-aware large language model, and it's a trained large language model to become schema-aware, and that's the Fact Engine architecture. Thanks for watching. I hope you enjoyed the video. If you like the video, please hit like and subscribe, and I'll see you in the next video.